Hello, discrete math fans. Let's take these statements and decide if they're true. We also would like to write down the contrapositive and negation of each one. So the first one is, for all x in the reals, x squared is bigger than or equal to 4 implies x is bigger than or equal to 2. The second one is, for all n in the integers, n is prime implies n is odd. And finally, being divisible by 4 is a necessary condition for being divisible by 12. All right, A is false because x equals negative 100 serves as a counterexample. If we plug in x equals negative 100, we can see that x squared bigger than or equal to 4 is true. If you square negative 100, you'll get a really big number. But x bigger than or equal to 2 is false. Remember that a conditional statement is false provided the first part is true and the second part is false. The contrapositive is, for all x in the reals, x less than 2 implies x squared is less than 4. And the negation will be, there exists x in the reals such that x squared is bigger than or equal to 4 and x is less than 2. So remember, when we negate that statement, first we change the for all to there exists, and then we negate the inside. And then negating the inside, if you have a P implies Q, to negate that, you'll get P and not Q. Part B is also false, and there's only one counterexample. That would be n is equal to 2. The contrapositive of the statement is, for all n in the integers, n is even implies n is composite. And finally, the negation would be, there exists n in the integers such that n is even and n is prime. And we can see that that statement is true using n equals 2. All right, part C, let's rewrite the statement with our formal logic. Now remember that when we have the statement of the form P is a necessary condition for Q, that can be rewritten as Q implies P. Furthermore, the statement as it's written has an implicit quantification over the integers. So let's rewrite the statement that we were given as follows. For all n in the integers, 12 divides n implies 4 divides n. Now this statement is true. It's pretty easy to see that if you have an integer that's divisible by 12, then certainly it will be divisible by 4. The contrapositive will be, for all n in the integers, 4 does not divide n implies 12 does not divide n. And then finally, the negation would be, there exists an n in the integers such that 12 divides n and 4 does not divide n. Okay, that's all for now.